40 meters underwater, zero visibility, crushing pressure. For centuries, that was a job for the bravest divers on Earth. Then China sent a robot instead, and that changed everything. Let's start with a bridge. Not just any bridge. The Yangtze River Bridge, a structure so enormous that engineers realized early on that traditional methods simply wouldn't work. Here's the challenge. The Yangtze River isn't a calm, peaceful waterway. It's one of the most powerful rivers on Earth. The currents are brutal. The sediment at the bottom shifts constantly. And to build a cable-stayed bridge with a main span of 1,208 meters that's longer than 12 football fields laid end to end, you need to plant the foundations deep, really deep, into that dark, unpredictable riverbed. Traditionally, that means sending divers down. Human beings in pressure suits, navigating zero visibility, trying to drill and clean and position things with precision in conditions that would terrify most people just to hear about. It's slow, it's dangerous, and at this scale, it's nearly impossible to do consistently. So China's engineers asked a question that changed everything. What if we build a robot that's never existed before? Meet the world's first intelligent caisson robot. Now, a caisson in simple terms is basically a giant hollow box that gets sunk into the riverbed to form the base of a bridge pier. Think of it like planting a massive concrete tube into the ground, except the ground is underwater and filled with shifting sand and mud. Getting that tube perfectly positioned, perfectly clean, perfectly level, that's the job. The AI caisson robot handles all of it. It drills through layers of sediment with flexible, adaptive arms that can navigate around rocks and unexpected terrain, things that would stop a regular machine dead in its tracks. It uses real-time sensors to constantly monitor what's happening around it, adjusting its movements on the fly. And one of its most critical jobs, cleaning the corners. Here's something most people don't know. The corners of a caisson are the hardest part to clean. Sediment builds up there, and if those corners aren't perfectly clean before the structure is sealed, the entire foundation can shift over time. In the past, that job fell to divers working in near-zero visibility, by hand, in dangerous conditions. The robot does it in a fraction of the time, with perfect consistency, every single time. And the result? After 6 years of construction, the Yangtze River Bridge officially opened to traffic in September 2025. Built under some of the most difficult river conditions in the world. But here's the number that really puts this in perspective. 1,208 meters. That's the main span. That makes it the longest cable-stayed bridge span on Earth, a new world record. The full crossing stretches 10.3 kilometers over 6 miles of bridge, cables and steel, connecting two sides of the Yangtze in a way that has never been done before. And there's one more thing that makes this bridge unlike anything ever built. It doesn't just carry cars. The Yangtze Bridge carries an expressway, a regular road, and an intercity railway all on the same structure, at the same time. That has never been done on a bridge of this size anywhere in the world. The robot that helped make it possible, it's already being prepared for the next project. Now, bridges get the glory. The photos look incredible. The engineering is jaw-dropping. But there's another type of infrastructure that holds a country together just as much, and it almost never makes headlines. Roads, specifically highways. The kind that carry millions of trucks, buses and cars every single day. The kind that, when they crack or degrade, cost billions to fix and cause economic ripple effects across entire regions. China has over 177,000 kilometers of expressway, the largest highway network in the world. And keeping that network in top condition is an engineering challenge of its own. So, in 2024, China decided to upgrade one of its most critical arteries, the Beijing-Hong Kong-Macau Expressway, known as the G4, a highway that runs the entire spine of eastern China, connecting the capital to the southern coast. A stretch of 157.79 kilometers, crossing Henan and Hubei provinces, needed to be completely resurfaced. That's not unusual. Highways get repaved all the time. What is unusual is how they did it. Sany, one of China's largest construction equipment manufacturers, deployed a fleet unlike anything that had ever been used on a road project before. And leading that fleet was a single machine that immediately broke a world record, the SAP 200C10, a paving machine so wide, so precise, that it can lay fresh asphalt across 19.25 meters in a single pass. To put that in perspective, most standard highway pavers cover about 8 to 12 meters at most. This thing nearly doubled that. One machine, one pass, almost 4 full lanes of perfect asphalt laid down simultaneously. World record. Confirmed. But the paver didn't work alone. Behind it rolled a formation that looked more like a military convoy than a road crew. 6 double-drum vibratory rollers, each weighing 13 tons, followed in precise formation, compacting the fresh asphalt layer by layer. Then came 3 rubber-tired rollers, each one 30 tons, smoothing the surface to an almost mirror-like finish. The formation is called 1 + 3 + 3 + 3, 1 paver. 3 groups of 3 rollers each, moving together in perfect synchrony like a mechanical ballet across the highway. And here's the part that takes this from impressive to extraordinary. Every single one of those machines is autonomous. They're guided by China's own Beidou satellite positioning system, the Chinese equivalent of GPS, but with centimeter-level precision. Not meter level, not foot level, centimeter. These machines know exactly where they are, at all times, to within the width of your thumb. They're also connected by a low-latency 5G network, letting them communicate with each other in real time. If the paver slows down, the rollers adjust. If one roller detects a problem, the others adapt. AI algorithms are constantly optimizing the formation's speed and pressure based on temperature, humidity, and the composition of the asphalt itself. And if something goes wrong, electronic fences keep the machines within precise boundaries. Obstacle detection systems can identify a hazard in milliseconds. Emergency stop systems can freeze the entire fleet instantly. The result? 0 edge trimming errors, fewer joints in the road, which is actually critical, because joints are where roads start to crack. A smoother surface, a more durable surface. And a job that would have taken a massive human crew weeks to complete, done with a fraction of the manpower. Think about that for a second. This isn't a factory floor. It's an open highway, in real weather, with real-world conditions. And China managed to automate it to a degree that most countries haven't even attempted in controlled environments. Okay, we've talked about a world record bridge. We've talked about a self-driving highway fleet. Now let's talk about the machine that might be the most dramatic piece of construction equipment ever built. China calls it the SLJ 900/32. The rest of the world calls it the Iron Monster. Built by Beijing Huaojoint Machinery Company, the Iron Monster is, in the simplest terms, a bridge-building machine. But that description does it almost no justice. Here are the numbers, because the numbers are the only way to begin to understand this thing. Weight, 580 tons. That's roughly the same weight as 3 fully loaded Airbus, a 380s, the largest passenger aircraft ever built. Length, around 91 meters. That's about the length of 9 double-decker buses lined up nose to tail. Width, approximately 7 meters. Height, 9 meters. And what does it do with all that mass? It picks up bridge segments, individual sections of a bridge deck, each one weighing anywhere from 800 to 950 tons, and places them with extraordinary precision, one after another, building a bridge from the inside out as it rolls forward on its own legs. Here's the mind-bending part. The Iron Monster doesn't just sit next to a bridge and lift things into place. It actually walks across the bridge it's building. It moves forward on the completed sections, reaches out over the gap ahead, and places the next segment, then shuffles forward again and repeats. It looks like some kind of mechanical spider, slowly consuming the horizon in steel. Before machines like this existed, placing a single massive bridge segment took weeks. You needed enormous cranes, massive ground support, complex rigging systems, and dozens of highly skilled workers operating in dangerous conditions, especially for China's high-speed rail network, where many bridges cross rivers, valleys, or existing roads. The Iron Monster does it in hours, not days, hours. And because China's high-speed rail network is the largest in the world, over 45,000 kilometers, and still expanding, machines like this aren't a novelty. They're a necessity. Without them, China's rail ambitions would simply be impossible to achieve at the pace they've set. There's a famous video that circulates online showing the SLJ 900 32 inches action, crossing a valley in what looks like a slow-motion science fiction movie. Watching it, it's almost hard to believe it's real, that a machine this size, built by human engineers, is casually rearranging the landscape. But it is real. And it's been in operation for years, steadily, relentlessly building the infrastructure that connects a country of 1.4 billion people. Why is China doing this, and why now? Okay, so we've seen the robots, we've seen the machines, we've seen the records, but here's the question that really matters. Why? Why is China investing so heavily, so aggressively, in construction automation at this scale? What's the actual story behind the machines? Part of the answer is economic. China's labor costs have been rising for 2 decades. The low-cost manufacturing advantage that defined the country in the 1980s and 90s is no longer as sharp as it once was. Automation isn't just about building faster, it's about building smarter, with a shrinking pool of workers willing to take on physically brutal, dangerous construction jobs. Part of the answer is demographic. China's population is aging. The generation of young men who flooded into construction sites in the 1990s and 2000s is getting older. And the next generation has different expectations, different careers in mind. Robots fill that gap. But there's a third reason, a strategic one. China understands something that a lot of countries are still figuring out. The country that controls the best construction technology controls the terms of global infrastructure. Through the Belt and Road Initiative, China has been building roads, railways, and ports across Africa, Asia, and Latin America. Every new robotic technology it develops isn't just for domestic use. It's a potential export, a product, a form of influence. When the world's first intelligent caisson robot successfully helps build the world's longest cable-stayed bridge span other countries notice. When a self-driving highway fleet resurfaces 157 kilometers of road with 0 errors, other governments start asking questions. Who built that? Can we buy it? Can we hire them? China's construction technology is becoming a kind of soft power. Quiet, but enormously effective. And here's where it gets interesting, because China isn't the only country watching this space. The United States, Germany, Japan, South Korea, they're all accelerating their own construction automation programs. The race isn't just about building bridges. It's about who gets to write the rules of how the world builds itself for the next 50 years. The question is, what comes next? Because here's the thing. The machines we covered today, they're already yesterday's technology. Right now, in labs and test sites across China, the next generation is already being developed. Fully autonomous bridge inspection drones, AI systems that can design an entire highway route in hours, robotic systems that can operate in conditions no human could survive, and the rest of the world is scrambling to catch up. So here's what I want you to think about. If China can build a record-breaking bridge with a robot and pave a highway with a satellite-guided machine that drives itself, what happens when that technology spreads? What happens to construction workers in Europe, in America, in Southeast Asia when the machines arrive? Is this the greatest leap forward in human infrastructure since the Industrial Revolution? Or is it the beginning of something we're not quite ready for? Let us know what you think in the comments section. If you want to know what's coming, make sure you're subscribed, because this story is just getting started.